Hello again, it's me. This time with something more funny. I had this idea for a while now and now I've built it. And the idea was to use an old quad motor and an old ESC and the internals of a servo tester and mesh these together and build a contraption that can spin a spinning top to really high RPM. So I haven't done any research, so I don't see that anyone else did a much better job, and also I want to solve the problems by my own. So this is the machine I ended up with, the final product. I haven't tested it yet, but we will do so. And so the machine is ready. Then we have to make some spinning tops and of course a short recap on how I got to this point. So first of all, I've made some drawings by hand. Then I've made some Fusion 360 drawings on the PC, and here are the final drawings. Okay, let's get started. Here I am designing some stuff in Fusion 360, making the parts, la-di-da-di-da-di, and ready. My printer printing the neon yellow parts, my printer printing the black parts, me removing the neon yellow parts, me removing the black parts. Here I'm cleaning and preparing all the parts, and here I'm making the knob fancy with my logo on it and slow to fast indicator. That's me again. Making the 4 axles on the lathe out of aluminium, but I will upload the files on Thingiverse with all parts printable, so you can build your own if you want. Okay, the next day, in the middle of the night, preparing all the parts for the assembling. Here we can see all the parts we need, nicely laid out, including O-rings, bearings and all the screws. So it's time to assemble the machine and test it. But as mentioned at the beginning, we still need some spinning tops to test the machine. So let's make some. The first one is out of wood and painted red. And the second one is made out of brass with an aluminium core, and the top is made out of steel screw. So if you are still watching, you have seen how the machine was built, and now it's time to test it. So we have the spinning tops here, the wood one and the brass one. The brass one needs to assemble. Then we have a small 3S LiPo to power the machine, and if we do the math correct, The motor is 2206 with 2100 kV, and if we power it with a 3S LiPo, with a 3-cell LiPo, we will get around 26,000 RPM. The main wheel is about 34 millimeters, and the shafts, the shaft of the wooden spinning top is about 10 millimeters, and the shaft of the brass aluminium spinning top is about 8.5. So roughly 9 millimeters. So if I have done the math correct, we will get about 100,000 RPMs on this spinning top, theoretically. But I think we will far off that number. If we can create maybe about 10,000 to 20,000 RPM on the spinning top, it should be a success. For me, it's a success. So the idea, not sure if I have explained it. The idea is pretty simple. We have this big spinning wheel on the bottom. We have two smaller counter wheels which are spring-loaded over the 4 axles, and so we can grab any round object, any shaft, pinch it between the 3 wheels, throttle the one wheel up and release it. That's simple. So I think we are ready for testing. I haven't found any good surface, so I will use this full cartridge of gas. No idea if this is a good idea or safe, but it has a very nice concave bottom, and I think we can spin the spinning tops pretty nicely in there. So let's get to the testing. So first of all, we are testing the wooden one, just with a slowly. Okay. Ooh. Okay. Try again. Holy moly. Whoa. Okay, let's try again. Okay. The 10mm shaft is kind of too thick, but we will go for it anyways. Okay. Perhaps a concave bottom is not the perfect surface. It's still spinning on the ground. Okay. So I think we will just test it on the floor, but yeah. Let's try the metal one. No idea what happened there. No idea what's going on. It has so much grip. Holy moly! And it's bent. Oh, what the fuck? Oh no, it's bent. So I will make some small repairs and try it again. So we are back in business. It's still pretty bendy, but okay. Now we will try it on the floor. Okay, the O-rings are expanding under the high RPM and just pinching the shaft, so the spinning top won't release. I will try it. Okay, it's melted. Oh no. Okay, we will try again. What the fuck? What the fuck? It's still spinning somewhere. Oh, under the chair. Under the chair. Okay. There it is. Okay. Oh man, I have red marks all over the wall. Okay, I think this was not really a success. Let's try again. So the O-rings came loose. But didn't break. And the rubber of the wooden spinning top came off. Probably it's not necessary because it has enough grip. So let's try again. Let's try again. Is it in focus? Yeah, kind of. Just on the ground. So let's build something so we can keep the spinning top in the frame, in the shot. Or let's try first the bendy metal one again. Probably this one will stay more on the same place. So back again. Is it in focus? Kind of. Not really. Okay. So I've tried to bend it back. Let's try again. It just cut the zip tie in half. It's pretty violent. So again. What the fuck? So finally a success. The metal spinning top was spinning 5.5 minutes with the machine throttled up to about 30%. In the upper right corner you can see the wood spinning top filmed with 250 frames per second, and the footage is slowed down 10 times. So here you can see how fast the O-ring is accelerating after touching the wire. So there are pretty high forces even with little throttle. After some small modifications on the metal spinning top and using glass as a surface, I got constant runs over 10 minutes with about 50 to 60% throttle. So, conclusion. The machine is pretty violent and kind of useless. And it destroyed one plate, one showcase, and made many dents in the walls and the floor. But it was fun to play around and scare the kids, so kind of a success. And I have enjoyed the designing and the building, so that is the most important part for me to make it a success. So thumbs up. That is all for today. Have a nice one, and until next time, bye.